Find the length of the curve given by x equals 5t squared, y equals 2t cubed, where t ranges between 0 and 1. Well, recall that the arc length of a curve in parametric form is given by the integral from a to b, the square root dx dt squared plus dy dt squared dt. Okay, so a little bit of work is going to get us there. Dx dt, x is equal to 5t squared, so dx dt will be 10t. Dy dt, y is equal to 2t cubed, so dy dt will be 6p squared. T ranges between 0 and 1, so there are our A and our B. So the arc length will be equal to the integral from 0 to 1, the square root, dx dt, so 10t squared, plus dy dt squared, so 6t squared squared dt. Squaring those terms in the radicand, we get the integral from 0 to 1, the square root of 100 t squared plus 36 t to the fourth dt. Notice that in here we have a factor of t squared in both terms, so we can factor that out. Factor out a t squared. We're left with 100 plus 36 t squared dt. Thankfully, square root breaks up over multiplication. So this would be the same as the square root of t squared times the square root of 100 plus 36t squared. The square root of t squared, the square root and the square go away. Those are inverse operations as long as t is positive, which we're in the interval from 0 to 1, so t is positive. So this is the integral of, from 0 to 1, of t times the square root 100 plus 36t squared. So we just have to figure out how to get this integral done. And this is going to be a substitution, so we're going to let u be equal to 100 plus 36t squared. In that case, du is equal to, well, we got to bring down the 2, so 72t dt. We're in pretty good shape as far as our substitution goes. We've got t dt, but we need a 72 in there. So we multiply by 72 on the inside, divide by 72 on the outside. So this becomes 1 over 72. The integral, we're changing variables, so our limits of integration would change, but we don't really care what they are at this point. Square root of u du. Square root of u, remember, is equal to u to the 1/2. And when you integrate, you add 1 to the power. So u to the 1/2 plus 1 is u to the 3/2, and then you have to divide by that same number. And we evaluate that, the limits of integration. Now we can go back and back substitute. U is equal to 100 plus 36t squared. So 1 over 72. Dividing by 3/2, note, is the same as multiplying by 2/3. So let's do that, times 2/3. U is equal to 100 plus 36t squared and that's raised to the 3/2 power. Now that we're back to t's, we can evaluate from 0 to 1, which was our original limits of integration. Okay, we can also cancel this 2. We'll go into the 72 36 times. 36 times 3 is what, 108. Now we put in the 1 first, so 100 plus 36 times 1 squared to the 3/2 minus 100 plus 36 times 0 squared to the 3/2. One over 108. The 3/2 power is the same as the square root cubed. 100 plus 36 is 136. So we got the square root of 136 cubed minus 0 squared is just 0. So thankfully this is just the square root of 100 cubed. Then it's a matter of doing some simplification. Note here that 136 is equal to 4 times 34. And that's cubed. Minus the square root of 100 cubed. Square root of 4 is 2. Square root of 34 is irrational. Pardon me, I said 34 and I wrote 37. Square root of 100, of course, is 10. Cubing 2 times the square root of 34 gives us 8 times 34 times the square root of 34. And cubing 10 gives us 1,000. So finally, 1 over 108. 8 times 34, 8 times 4 is 32. 24 to 72, square root of 34 minus 1,000. So there's the length of the curve given by that set of parametric equations on the interval from 0 to 1.